This goes with Desmos, but what I'm going to do here is go ahead and graph e to the x and then make my Maclaurin polynomial of 1 plus x squared over 2 plus x to the third over 3 factorial. So that's right there. And hypothetically, let's say that I want to estimate the error whenever I am approximating f of 1. Okay, now remember that whenever I'm using my little Taylor polynomial approximation here, I'm using the next term for this approximation here. So the next term is going to be x to the fourth over factorial times my maximum derivative. So remember, that is going to be the same thing as saying error is less than or equal to my maximum derivative, my maximum fourth derivative in this case, x minus c to the 4, and then 4 factorial. Now, the reason why I particularly picked e to the x is because it's easy for us to take the derivative 4 times, because the derivative of e to the x, no matter what happens, is just e to the x. And remember that whenever we are trying to find the maximum derivative, we are essentially looking at the center, and we are looking at the x value that we are trying to approximate. In this case, from 0 and 1, if I were to look at that in terms of my function here, you'll obviously that my maximum derivative is going to be at e to the 1. So whenever I'm looking at my fourth derivative here, my max fourth derivative to be precise, that's going to be e to the 1. My x value is going to be 1 minus my center being 0 to the fourth power over 4 factorial. So notice that this right here represents my maximum error. Now, hypothetically, if I were to write this out in terms of my actual error, where I have f of 1 minus p sub 3 of 1, my actual error is 0.051615, aka if I were to do 1 f of 1 and 1 p3 of 1, we get this difference right here, and this difference right here is 0.0516. So you can see that this right here is definitely less than 0.1132. Now, let's say hypothetically, once again, we aren't given something like e to the x, because obviously you won't get anything pretty like this, but you might get something like what we did on number 2 here, where we approximated the cube root of x. So what we're going to do here is do the same thing step by step again and see how this is going to be less than or equal to 0.003442, and then we'll actually figure out what the actual error is. So the cube root of x, let me do another thing. So we have the cube root of x. And for this one, we are doing a degree of 2. So if I have that being x to the 1/3, then I know that my derivative here is going to be 1/3 x to the negative 2/3. And then my second derivative here is going to be negative 2/9 x to the negative 5/3 right here. Okay, so what we're going to do now is use my third degree Taylor polynomial here. And we didn't do this in class, but it is good practice because you'll see the third degree Taylor polynomial. So that if I were to evaluate this at a center of 8, and we are approximating it at 7. So if I have a center at 8, I'm going to have a 2 plus 1/3 8 to the negative 2/3, and honestly, I'm not simplifying this. X minus 8, and then minus 2/9, 8 to the negative 5/3, x minus 8 squared. But then don't forget about your little 2, so we're going to divide everything by 2. And this gives me my polynomial approximation here in terms of 8, which is right here. Now, what we're going to do here is approximate 7. So what I'm going to do here is do f of 7. Well, first let me do this. 7, f of 7, 7, f of 7. Let me do g, because, oops, oh, my beta, what's going on? Let me do, oh, okay. It didn't like that. Let me, ooh. Okay. Okay. Now if I zoom in, okay, there we go. Let me do that to be in green, and let me do this to be red. All right, so my green is going to be my Taylor approximation, and then my red is my actual function right here whenever I zoom in. So then we could look at the difference, and that difference right here, if I were to say f of 7 minus the 3rd degree polynomial at 7, my difference is 0.000263. Okay. Now, if I were to use Lagrange, remember that's going to be my maximum derivative. So error, let me just copy from here. Error is going to be less than or equal to my maximum 4th derivative, x minus c to the 4th over 4 factorial. And the problem with this one here with the cube root of x is that I got to figure out what the 4th derivative is. Well, no, wait, just kidding. Not the 4th derivative. This is 2. This is 2. This is 2. This is 3. This is 3. And this is 3. Okay. Anyways, the 3rd derivative. So we are going to find out what the 3rd derivative is. And that is 10 over 27 x to the negative 8/3. Now, you'll realize that this is a decreasing function like we said this morning, and if it's a decreasing function, we are going to look at the lower value in terms of 7 and 8. My lower value is 7, so I'm going to plug in 7. So my maximum 3rd derivative is going to be 10 over 27, 7 to the negative 8/3. X is going to be 7. My center is 8 to the 3rd power, all over 3 factorial. And remember that this is absolute value, so make sure that you include that. And this right here represents my Lagrange error. And you'll notice that once again that my actual error right here of 0.0002 is less than my approximate error, my approximate Lagrange error of 0.0003. Now, once again, hypothetically, I don't think you'll be asked to find the actual error. I think what you'll have to do is find the Lagrange error and call it a day in terms of these types of problems. But once again, you can see that here and here, they're pretty, close to each other. And as the visualization again, here's what my graph looks like whenever it's zoomed out from 0 to 14-ish. All right. So that's basically another visualization of Lagrange in terms of numbers 1 and 2.